I mean, when you go to the, I was just there 2 seconds ago. When you're coming here, it says 2.6. You see that? So that's the one that we are going to, so these are the things we're going to go through. That's the last thing. So, and nothing after that, okay? It's going to be full programming. As you see, quiz 2 is not happening. So we're going to have 3 quizzes after the semester, okay? 3 quizzes after the semester. We are kind of on time. We are not behind. Next week's lab is not, it's going to be online. We know that, right? So please don't come to the lab. Go online, and we're going to go through the lecture. If we have time, we can do a review on demand on the topics that you want in one of the sessions before the test. I think that will be beneficial. Sadly, your lab is before your lecture. So it has to be the week before. So next week today, something like that. So it is going to cover yada, 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 yada. Look at the addendum. It is going to be complete the program in types of complete the program, which essentially means I'll give you a class, and I say, you see this class? Develop that feature of it and nothing else, and assume everything else is developed. So you can actually reuse that and develop whatever you are using. So, or I'm going to ask you not to. So, for example, if I'm giving you a class with rule of 5, and I say, do the move constructor, you cannot just call the assignment operator done. You can't do that. Okay, so I'll tell you exactly what you can and cannot do. Okay, so follow the instructions, please. Read the instructions and do it. You will be fine. So complete the program. Write a complete program, okay? Which I'm going to ask you, write a complete program that does that to see if you can actually do it, if it fits, okay? The details is going to come up exactly like you did for the quiz. So the details is going to come up in a, you know how I do it, like, sorry, so yeah, we're not my students. So another test agreement is going to come up. In that one in detail, I'll tell you exactly what the questions are, okay? As usual. So you know what the questions are before you come to the test. And this time, please study, okay? Yes. Like how early? 1 week. It doesn't make any difference. I can give it to you tomorrow if you want. No, I can't, because it's not designed. It's not designed. You have to design it. So if I design that, then marking of quiz 1 will be later. You cannot blame me on that. Okay, people at home, let me just poll over here. We all have computers over here, right? So I'm going to issue a poll, and you're going to tell me. Oh, sorry. Go ahead. One more time. One more time. Sorry. 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 There you go. Keep going, keep going. Lindsay, go ahead. Hamza, Lindsay, if you're full screen, you have to get off full screen and do the poll. Charles, where are you? Oh, Charles did it. Lindsay? Lindsay is sleeping? No, Lindsay's there. Okay, let's publish the poll. So 21% says mark the quiz first, and 80% says, okay. So I'll do the question first, and then I'll mark the quizzes. Few of the quizzes are marked. I cannot post it. I went a little harsh on the quiz one. So I didn't mark like myself. Okay, usually I give marks. But this time I marked you like OOP345, which means, for example, if I ask you to move or do a copy and you started allocating, remember it was an array of pointers, right? And to deallocate, you went through the array to the size of the number of things, but you did your deallocation wrong. If it was OOP244 because you did the loop and you went through it, that would gain you mark. It means you understand what a loop is. You know what does it mean to go through the array. You know how the deallocation works. But when you deallocate incorrectly in 345, loop doesn't matter. You should know by now what a loop is. I shouldn't mark you and praise you because you wrote a for loop. Okay? I should mark you on properly deallocating the thing. So you lost the mark for it in the marking that I've done now. Okay? Just to demonstrate how you will be marked. No, to demonstrate how you should be marked. I'm not going to mark you that way. I'll be easier next time. But for first one, I'm marking you precisely. So the mark you are getting is your knowledge mark. Okay? Which means I'm waking you up to study. So it's going to come up soon. I'll try to design the questions as soon as possible. So how do I design the questions? I'll go through the samples that I have written. I'll take a look at them and the concepts that we have, and I come up with something that covers everything. Okay? All the things that we have, you'll see what the questions are. And I'm going to post the questions, then immediately I'm going to start marking you guys. Okay? Sorry for the 4 people who said mark the quiz first. So you guys have to wait. Yes. You got to get the marks before the midterm. Oh, yes, of course you do. Oh, yeah. You got to get the marks before the midterm, but usually the reason that I always mark the midterm 2 days before, because I'm weak. When I design, I give up the questions. But now I give up the questions anyway. Then it doesn't matter. I can do it now. Okay? So it's going to be types of complete the program, write the complete program. So write a complete program, you need to have all the header files and everything. Complete the above thingy, then you have to read and see what is, I'm going to tell you, assume everything is included. Then you know you don't need to do that. So please read the questions. It's extremely important. Write a complete program. And write a code snippet. The details will be posted in the midterm agreement that will be posted under midterm section of the subject content. Okay? So you will see that. You will see exactly what the details are, and that's that. And if you have any question, you can always ask, and we'll go through it. Okay? You're good with that? So I will post the agreement as soon as possible. And then complete the marking of quiz 1. Anything else you want to know about midterm? See, nobody's coming through this thing. So let me send them an email. I'm sorry, this thing didn't work. Newnham campus, right? So E-class. Anyways, so any questions about the midterm? We're good? Okay. No, several questions. Several questions, there's no backtracking. Remember that. You don't go back. You see the question, you answer, you're comfortable with it, you go forward. Okay? I'm going to mention what is the percentage, weight percentage of that question. Okay? Based on the number of, so when I'm writing the answer myself, some example of a correct answer for the thing, I see the number of lines that it has. That becomes the weight. So if one of them is 4 lines, the other one is 10 lines, the other one is, I'll add them all up, I'll give you a percentage. This has 20% of the coding. This has 50%, so you can time yourself, okay? But again, because you have the entire 2 periods only for programming, there is plenty of time. Please pay attention to the questions. For heaven's sake, read the question, please. My pants would get dirty, otherwise I would go on my knees and beg you to read the questions, please. Okay? So 2. So it's, what is it? It's E-class, Newnham, the projectors and speakers. This is K 30, what is it, the room number? 30, oh, it says, pardon me? 3010. 3010. You're sure, right? They're not going to go somewhere else. Okay. The projectors and speakers don't work. Let me see if I can't. Can I close it? No. I'm just trying to see if the yeah, so the although it's at a, why is it showing the door? Hello. Okay. Ah, there you go. So it works. So that's working. Good. So the projectors and speakers don't work. The projectors and the speakers in K30 do not work. Please help. Okay, so that's that. Okay. So last chance. Any other question before we begin? This is good? And the okay. So the midterm program, the midterm, that's one. Now let's talk about the concept and debugging test. Debugging part of midterm will be on, okay, our labs, you said, is on Tuesday, right? Which means on March 4th. March 4th during the lab. During the lab, you are allowed to bring 1 scrap paper for your walkthroughs with your name on both sides, readable from 3 meters away. Away with the naked eye. Okay, I'm wearing lenses, 3 meters. If I can't read it, I'll collect it. When I see, I should be able to see over there. Who are you? Okay? You have to have your name on it. Huh? Why you want to do scrap paper and coding? Scrap it on Notepad. Notepad++. Why you want to scrap it? Okay. 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 So that's that. Oh, sorry for all that typos and stuff. It doesn't matter. So I'm just going to send it like this. And we know what it is. We know what the dates are. Let me just make this bold. And we're done. Okay? Post. So that's that. Yes. No, I'll give you in that agreement thingy, you're going to see the exact weight. Usually what I do is around 60%, 70% of the mark is coding. 30%, around 10, 15% is concept, 15% is walkthrough. So 70% is always coding for me. Okay? That's usually what it is. All right, so somebody's coming actually.
Professor,
Yes.
the backtracking thing, as you know, some of us you usually do the easiest one first, and then we later handle the more complicated ones.
Mm-hmm.
But here is the case: we cannot go back. Let's say question one is more complicated, but then I'll be able to do question two as fast as I can, and then maybe I can just skip it and go do question two and maybe question five, and later on I'll come back and then do the more difficult
The
one.
problem that I have is that I know that's very noble. That's very nice. But usually people try to find the
Yeah.
same question and then watch each other writing. So I may
Oh,
enable the backtracking. We'll see. So I'm not going to make the good students suffer because of the cheaters. So probably I'll allow the backtracking. I'm not 100% sure. I have to see what facilities I can
yeah.
use.
It will be grateful if you do that. Make it possible for us.
Okay. All right. Okay. Forsan is saying that. So Forsan, you have to sit right in front of me. Okay.
No, no problem. I will sit right in front of you.
Okay. Sure. Okay. All right. All right. Okay. So we'll see. I'll try to. Well, we'll see what happens. Okay. I'll keep that under consideration. No promises, but I'll do my best. Okay. So that's that. Uh, and let me just. I'm just trying to delay the thing so they come and fix the projector, but we'll see. Anyways, let's go back here. Where is my? There you go. Okay. Um, there are two things that is extremely important for us to get ourselves familiar with. One is the templates, standard template library, which is essentially 1.5 million of different uh, templates that you can use to organize your code containers, essentially they are. And the second one are algorithms. Algorithms are the most common algorithms that you need to use in your applications that you write. and it's just using this, you're going to be quicker. Okay? So essentially, all the things that you do, they're already done for you in forms of templates and in forms of helper functions, let's put it that way, okay, where you can actually use to do your stuff. The most common thing, the very first thing that everybody begins talking about is vectors. So a vector is essentially, if you recall, we created an array, right? We created a template for an array or something we did. Okay, it's something like that, but the difference is that it's much more efficient than an array. Okay, so to bring the, oh, hello. Okay, everybody's looking at their monitors, so let's see if we can. And this thing doesn't work, does it? Yeah, it is projecting. Apparently, this is supposed to now be up there. It's connected, and it's blank. If I remove it, you'll see it's going to remove. So it is connected. If that thing works, I'm going to kill myself. No. So that's not the one. That's the USB. This is the HDMI. It is connected. It is connected. This works every day, every single time. So there's nothing wrong with this system. This is the. So put it on, I'll show you. Wait. See? 1 or 2 and 3. So it is connected. This is the display that goes on the screen, and that's my secondary. Yeah. Let me just turn this on, maybe. I don't know. Yes. I turned on the podium too, just in case, like, if that comes up, I want to see. Oh, that one? No, I don't know what is that. Okay. So where did you connect me to? So you bypassed it? Oh. The one for the laptop. Oh, I see. I connected it with the one for the PC. Oh, I see what happened. You see what? Got it. So it's as if I'm connected to the podium now. Got it. This one is not. Can you try using the camera too? Sometimes, but I don't think. Let me check to see if the camera works. I don't think it's going to work. If it works, wow. No, it's not. That's me. That's this camera. No, I don't have a second one to switch to. So no, it doesn't work. The camera is not going to work. That's okay. No worries, no worries. I'll use the camera over here, project it over here. I'll use that webcam. That's a good workaround. Thank you. I'll remember that.
I can't hear you, Professor.
Oh, you can?
Oh,
You can?
okay.
Oh, yes, the microphones are gone. Give me a second. I'm going to do another microphone. For that, I have a solution too. Give me a second. I have a solution to microphone array of mine. Where is my microphone array? It says, don't worry. Give me 2 seconds. Give me 2 seconds. People at home, can you hear me? Can you hear me?
Yes, right now.
Fantastic, thank you. So I'm moving
Yes,
this now. Okay, good. All right, is it clear, my voice?
very much so.
All right, okay, all right. So yeah, well, we are trying to, okay, so you're, all right. Okay, all right. Okay, okay, sure. The class ends in an hour. All right, thank you. All right. Okay, so um, you can hear me at home, right? 1, 2, 3.
Yes,
Fantastic.
yes.
Okay, goody, goody. Okay, so yeah, things have changed a little. The gentleman came over here and kind of a workaround. So now we actually have, yeah, nice. Okay, so I was talking about what vectors at the same time. So what happened to my stuff? Let's put this one over here. Closed my apologies. Give me a second. All right. So standard template library, okay? I don't want to go through all these and go through. This is like a reference thing, okay? So what you see at the notes that we have is like a reference that has all the information that you need. But I'm going to teach what's necessary over here. Please look at what I'm doing over here. Then read that and see if you have any problem with it. Come to me. For me, going through every single thing over here and explain to you what it is just a waste of time. So what I'm going to do, I'm going to go talk about uh, string thingy. You know, I'm not going to go through that. String view, I'll talk about it later. But I'm going to go through the standard template library, iterators, containers, the things that are important. Talk a little bit about files, and then come back and forth and take everything as parallel. Okay? So I'm starting with vectors. So um, essentially containers and iterators. Um, vectors are the thing that is mostly used for containers because they have a combination of speed and at the same time memory management. Okay, so how do you create a vector? It's exactly like the array thingy that we created. So we can simply say vector over here and say create a vector of doubles. Okay, prices, something like that. Okay, and we can check to see if a vector is empty. If prices dot empty, then do whatever we want to do, and so on and so forth. So let me just bring it up. So all the containers that you see can be treated as standard data structure entities, which means you can push and pull. Push and pop. When you push and pop, what happens to a stack? You push, something is added at the top of the stack. You pop, something is picked up. Now in here, because it's a vector, you can treat it as a stack from either side. You can push and pop to the front, or you can push and pop the back of the vector, whichever direction you want. Or you can push at in front and pop as back and treat it as a queue. So you can do all these things that you want to do to a vector any way you like. But the most important thing is that you can actually treat a vector as an array, which means the index operator is overloaded for it, and you can go through it with a regular for loop, as simple as that. So that's it. You can see what is at the top of the thing. You can see what is at the back. And all these things are set up for a vector. Not only a vector, any other container that I tell you, because they're all inherited from containers. Therefore, they all work the same way. Your preference to work with one of them is to see what is the purpose of your program. If the purpose of your program is to use least amount of memory and it's not important to have speed, maybe you want to use a queue. Maybe you want to use an array. So you have to go through the specs of every single container and see which one is more efficient in what aspect of the program you want to write, and use that one instead. As easy as that. Okay? So we can use the exact same thing as we did for vectors, but we can use a DQ instead. It's doubly ended Q. What a Q is, this is what a queue looks like. I added the code. I gave you already the code for the stack and a queue to see what they are. But this is essentially what it is. And that's where the so this is a queue. So this is a marker that doesn't work. Today, everything wants to go wrong. Sadly, I have to draw with red. My apologies. That's the only thing I have. I think I left my good marker at the other class and picked up the bad one by mistake. Anyways, so, oh, you have a marker? Why? Thank you. But thank you. Thank you. Yeah, of course, of course. Actually, thank you. This is nobody's going to see that. Thank you. Much appreciated. Unless I destroy it, and I don't want to do it. It's one of those fine point ones. We need thick things, thick lines. Anyways, so what I wanted to say, so a queue has, like behind the scene, it's built up of entities we call nodes. So this is a node, okay? A node is an element of a queue or any type of data structure, container type of a thing like stacks and things like that, or trees. So a queue essentially has a part for data over here. So in here you are holding the data. And then it has two pointers of type node itself. So a queue in memory is like this. So as you see, each node points to the next node and points to the previous one. If the previous one is null, it means you're at the beginning. If last one. Now, the good thing about it is that when you have a queue like this, it is not in a contiguous memory, which means if I want to add something in the middle, this happens. I simply say, you point to this, you point to this, you point to next, you point to previous. And right in the middle of the data, I added what I had. Okay? So if I had an array, if I wanted to add one element in the middle of the array, so if this is my array, and I want to add something here, what do I have to do? I have to first create an array that is bigger. Then I have to copy everything down. Then I have to insert what I have. Then I have to copy everything. And then I have to delete that one. I have to point to this one. That's crazy. If it's a million, then I need to have a 2 and a 2,000,001 elements. Over here, you can just enter it halfway through. Difference. What is the difference? The difference is that if I want this element, using the address of the beginning, I can jump to it in a fraction of a second. In this one, if you want the fifth one, you have to start from the beginning and keep counting. So, faster, sucks with respect to memory, perfect with memory, extremely slow. That's what the reason that I don't want to teach you data structures. You go take the data structures. They're going to talk about all these. You're going to write this. The reason that I actually wrote it over here to tell you what do I mean when I say you have to go read the specs of your containers when you're using it to see what they are good for. When you create something like this, when you create an array container, if you resize that array, you need twice as amount of memory that the array has to resize it, which means you need ginormous amount of memory. And it takes a long, long time because lots of copying has to happen. And removing too. Removing is the same. If I want to remove this, all I need to do is to take this out and update the notes for previous and next, and it's gone. For the other one, if I want to remove, if we want to remove an element of an array, again, you have to take one that is shorter. You have to see which one you want to remove. You have to move everything over here, not this one, and the rest. And then, again, same problem. OK? Are we OK? Do we understand what does it mean? OK. So that's all the efficiency thingy that I wanted to talk about. All right. Now that we know that, let's continue with. So this is DQ. All the specs over here of which one is good and what manner is there. So in here, vector. The vector is class of yada, yada, yada. You see over here, a size of this class use contiguous usage storage locations for the elements and are nearly as efficient as arrays. They store the elements on free storage. So it can. So as you see, its vector is a marriage between the two. That's why everybody uses them. OK? And then you can go check DQ. It tells you exactly what is it for. And then you go for the rest of the stuff. One by one, list what a list is good for. So list is essentially the top one. List, when you say list, it's a linked list. That they call it a linked list. That's essentially that one. So go through that, read exactly what it is and how they work. They all, as you see, they all share the same methods. You see that? Pop back, pop front. Everything is the same. OK? So please check these things. So as you see over here, I just changed the vector to a DQ, and everything is the same. I'm using the same process to go through it. Now, how does an array work in C? An array works as follows. You have a the head of the array holding the address of the beginning. Then you have the index operator overloaded, passing some value, and that value is added to the address. Therefore, you jump to where you want to go, right? We need to have something similar, something that can act like a pointer that points to the elements of a container. But containers are not like arrays. They are objects. So address of beginning, they don't want to have something low level like that. Because of that, they created an object whose job is to keep track of where elements of a container is, and kind of acts like an array, but it's not an array. It's an encapsulated version. Sorry, acts like a pointer, but it's an encapsulated version of a pointer. Those things are called iterators. Iterators are classes that are within the container. So each container creates, you can create iterators for a container using the container itself, which means if I want to, for example, have an iterator and go through the elements of a vector, this is what I do. So the same thing, I have the double array for the double vector for prices. Now I'm going to say std vector double scope resolution iterator. That's the class in there. And I say out of that one, create an instance I. So I becomes an iterator that is capable to point to the elements of a double vector. If you want a DQ iterator, you have to have a DQ employee iterator E. Then that means it is designed to point to an element of a DQ of an employee or a list of a car. Got it? Now, how does it work? They try to make it look like pointers. So like pointers like plus plus and things like that actually work with it. But what you can do over here is something like this. Take a look. Take a look at the for loop over there. So I pushed back a few things into the price. You see that? Now in the for loop at line 12, I'm saying I is equal to prices begin. The begin method of all containers return an iterator that points to the beginning of the container. So I can say for I equals to prices begin and I not equals to prices end. It means keep going until you hit the end. Okay? So end is essentially one after. If it hits the end, it means there's nothing there. Okay? Then I'll go I plus plus. So the plus plus is overloaded to make the iterator to point to the next element, no matter how the container is implemented. If it's a linked list, it's going to go to the next node. If it's a vector, it's going to go to the next place in memory. Don't worry about it. It's fully encapsulated, which means works for everything. And if you want to actually access the element itself, they overloaded the target of operator, the asterisk operator. So when you put that one behind it, essentially that becomes a reference of the container. Okay? So that for loop actually works. So essentially every single hit that I do to that iterator, that's essentially the reference of the element of that thing. I could have used just an array over here. You know that, right? I could say it size the I equals to 0 and use an index for this. We could have. But iterators are much more efficient, and that's what we are going to use. So anybody needs me to execute that, or it's clear? You want to execute it? I was afraid that I thought it might not run, so so yeah, that's that. Okay, so essentially, if you do this, let me do something else. Give me a second. I want to have a scope so I can get into. So when you do this, essentially this becomes the value. You see that? It actually translates to that. And one by one it goes through it. And the iterator for each object is essentially inheriting from the iterator interface, and they have to overload all the things that matches the behavior for the iterators that can work with the vector. That's why you create an iterator, and it's only that I is only an iterator for a double vector. That's it. You cannot use it for a list. You cannot use it for anything. It's only for a vector of type double. Does that make sense?
Yes, Professor, I have a question about the post incrementation.
Okay.
So I++ works here is because in the vector arranges memories contiguously, right? So we cannot use I++ in DQ.
No, you can, my dear. Plus plus is not really plus plus. It's an overloaded operator for iterator. It's not really doing, it's not
So
adding
it doesn't
anything.
point.
This is actually an operator that is overloaded for iterators. You can use that for anything. Okay? And also we have...
I thought it points to an address.
No, that's the thing. It's not. You're not supposed to think that way. Think as iterator as an encapsulated version of a pointer. Don't think of it as, don't try to think of it of the implementation, but how it's used. You follow what I'm saying?
Yeah.
Otherwise,
yes, I think I can.
If it, just think about it. If they don't do that, then what is the point of object orientation? If you're supposed to think,
exactly.
Oh, it's a list and I can't go like that, then it's not going to work. That it has to work for everything, right?
Yes.
Just think of it as an
okay,
operator.
Thank you, Professor.
No problem. Just think of it as an operator overload. That's all. So, and obviously you can, let me just, let's look at this. So when I say auto I is equal to yada yada, because begin returns an iterator of prices, and because prices is a vector of type double, therefore auto over there will be a double vector iterator. And you don't need it to know that. You didn't need to know that, right? So that's what it's going to. So that auto thingy will work the exact same way. Iterator. Oh yeah. So you were saying it doesn't have to be another one. Why do I have two of these? You're saying, what if I have something like this, right? So you're saying you have another vector of double. Can I use this iterator for that? Yes. Okay, so let me explain first. So to just clear things up, let me go to this. Does this statement says it has to be prices? Any double vector. So it's not tied to anything. You can make it point to any double vector. Okay? another, you needed to have a vector. So if you had over here std vector int nums, something like that, then you had to have an std vector int iterator in to point to those. Two variables with the same name in a scope. It's still C language. It's not magic. Okay, you cannot have two variables object with the same name in the same scope. Okay, yeah, if it was in an inner scope, that's why I copied the other two, because they are in there, because now it's standardized. When you write, now it is standardized. When you write auto I, this I is in the for loop. This is the scope of I dies when for loop is done. That's why you can do it like that. If you wrote this code 10 years ago, you would have gotten errors in some compilers. I think it was actually Visual C that assumed that I is initialized in line 10.5, and it would stay alive after. So I had lots of problems all the time. I would write this, I would say, shoot, I have to take it out so it runs everywhere. I still have that habit. Every now and then I take it out and put it outside to make sure I still have that phobia. Okay? Yes. Yeah. Yeah, you just put auto. Then you don't need to create anything. So if I had over here something like and nums pushback, nums pushback 10. Now you can simply write over here then you don't need to create anything for it. Automatically, the second I is an iterator of an integer vector, and they both work. Here, okay, again, it's not magic. It cannot read your mind. Now think about it for a second. If I give this in a test to you, and I told you, what is the type of prices? Can you tell me? No. So cannot the compiler. You follow what I'm saying? You cannot use it for normal variable. No, you can't. No, you can't. My question is, can you write this? No, it doesn't know what is age. You need to assign it to something so it knows what's happening. At line 16, I'm saying auto I is equal to, so it knows what is the type because it's being equal to something. It's being assigned to something. Same thing happens over there. If I write auto something, I have to write over there 25, so it knows age is an integer. Otherwise, it doesn't know what it is. Auto is automatic. When it's automatic, you have to have something to be automatic about. Right? It's not, yeah. Yeah. Yes. Give me line number. What do I need to do over here? Oh, you're talking about range-based. Oh, yeah, of course. Range base is from here. They backward it so it works over there. I will come to it. Yeah. So this is this. What else do we have? Oh, okay. Let me bring this. So now I have an employee over here with all the good stuff an employee is supposed to have. A class, okay, with all the things, rule of 5 and everything. Okay, so that's my employee. Why is it giving me an error? Oh, because it's F employee. Okay. And now I can do the exact same thing with, for example, a list of employees. So as you see, everything works exactly the same way in all containers. It doesn't matter if it's a composed type or how you are working with it. It doesn't make any difference. And as you see, when I'm pushing back, take a look at what I'm pushing back inside of that list of employees. In a curly bracket, I'm putting two values that are actually matched to the constructor of what an E is supposed to be made up of. It automatically is casted, and a copy of it will be added to the list. Okay? So things like that are very normal. And I can insert, I can erase, I can remove, do stuff like that. So these are all, as you see, okay? So in here, what happens, I'm just showing all the employees. Then I'm inserting. As you see, I'm doing minus minus n. I'm saying insert to the end Homer Simpson. So it actually adds to the end of the list. Then I'm going to start from the beginning and show it again. Now I'm going to say erase one after the beginning. So it's going to delete the other ones. And this is a list. So you can erase and insert exactly. So you can find an iterator. Go through the list using an iterator. Point halfway through and say insert here. Because that iterator is pointing in the middle of the list, it's going to insert in the middle, exactly as I drew on a screen for you. You can do the same thing with other containers too, but they're extremely inefficient. You're not supposed to. Okay? And that's that. Make sure it works before. Yeah. So this is an introduction to STL. Now what I want you to do is to actually go home and actually read the STL. And then you're going to come back after the, because STL is not going to be in a test, right? I want you to please act like grown-ups, okay? Don't go beer drinking 7 days during the break, okay? 1, 2, okay. Another, the rest, the 5 days, really study break. It's not, woohoo, party break, okay? Please, I beg you, go read all these things, go through these notes, and come back with questions. I'm going to talk about files. we have a little bit of time. I'm going to start with files and kind of kick that one in too to see how files are managed and done in binary format, and then we'll see what we're going to do. So let me copy these, and I'm going to remove these. Bring the real employee in. So sorry if I'm not giving you a break, but you see, you remember what happened, right? So don't blame me on it. What is this? Is a vector. We don't care about this. So I'm going to say include employee. And let's look at our employee. This is an easier employee because it's for purposes of I didn't want to go bananas with it. So it's a simple employee with absolutely no DMA or any resources, so it doesn't need to be set in any way. So I have a print and a read. So you can say in a one glance what it is, right? Just it's an employee that has print and read, and you're good. Okay. So in my program, I'm gonna write. I need F stream. So OF stream. Yeah, why not? So I'm gonna go OF stream and create. Yeah, let's do it that way. A file nums.txt, and in here I'm going to create a double vector. Let me just bring this over here. And I go through the vector. I don't need the employees now. And just write everything in a file. We know what happens when I do this. If I run this program, I'm going to have a nums.txt. And that nums.txt is going to contain those values. We've done this in OOP345, right? The only difference over here was that I have a vector and I'm using the range base that you wanted, right? I'm doing a range base. Okay. So, but with the range base, you gotta be careful. If you don't put that reference beside the ampersand, the V that you have in the loop, every one will be a copy of the value. Remember that, right? In range base, you gotta be careful. Okay. So that's that. What I'm going to do. So this is, I know there's a gap in here, but I didn't go with what I planned over here. I had lots of things, but I had to kind of rush between them. So this is going to be file out. Right? Now see what I'm going to do in here. And instead of this, instead of this, I'm going to use this. So what the write function do? The people who wrote write function did it. I have no idea why they did this. I'll tell you what's going on. Remember that we created, we were teaching about void pointers? Remember that? And we said void pointers, you can put any address in it without casting because it's an address without type. Remember that? They didn't do that for read and write. Read and write for binary files is to dump the memory pattern of whatever you have into a file. So it doesn't reinterpret it. In the previous one, when I printed those numbers, it actually wrote the numbers as text in a file, which means it was actually converting the values from binary to text and put it in a file, which we did happily. Okay? But we will see soon that that's not the most efficient way to deal with a file. It's actually really crazy. So we, instead of interpreting what we have inside a variable, convert it to text and put it in a file, instead of doing that, we can just get a Xerox copy of the memory pattern of that object in memory and just copy that in a file. Why we have to convert it to text? Think about it for a second. Then I can read it and put it back exactly in the same object because the memory pattern is the same. I get all the information. If I don't need to read that file, if that file is only for storage purposes for my program, why do I need to convert it to text? Take a look. In here, oh, and I was saying, when they wrote the read and write, for some reason, they are passing character address, which means, because character is essentially a byte, right? They want to have an emphasis that writes byte by byte. So I'm going to say go to the address of the beginning of V, whatever it is, which in this case is the element of that vector, which is a double, right? And write from the beginning of that address to the size of V, which is a double. And write everything in a file. So after doing that, and I'm not going to call that in txt anymore, I'm going to call that nums bin. And if I run this program now, you will see that that nums bin is created. But the difference is that this is what it looks like. These are those doubles in the memory of the file. And I can just read it back. And it's going to be exactly the same. No difference. Okay? So. Oh, did I close it? Did I close it? Sorry. It was this one, right? Hopefully. Are we okay? You good? Okay. All right. So the right over here goes to the so the right what it does, it goes to the address of the beginning of whatever we pass to it, and it gets how many times it has to write that. Okay? If it was an array, that was very inefficient. I wouldn't have done that. I wouldn't go through a loop. That's stupid. If I had an array of 50 integers, I would simply give the address of the beginning of the array, and size of would be size of an integer multiplied by 50. And I would write everything in one shot. Why going through a loop, right? So again, remember, write writes from the beginning of an address to the size of what you are putting in the memory. And now I'm going to do something nuts. Take a look at this. Oh, not here. Let's first do this. So now I'm saying IF stream. You could have done F stream. You could have done F stream and then said iOS in and an OR, single line, bar, and then iOS binary. But IF stream just, it's the object that is for reading. So I'm saying read into the add, and again, but as you see, this one is not constant character anymore. It is regular character. So I'm saying go to the file, convert the address of double V into a character pointer, and read size of a double from the file into it. And then I print it out. And when I do that, this is what happens. Remember, we just created that nums bin. So when I do that, this is what happens. Reads the first double. And the good thing is that I don't need to have any comma separation and things like that, because the size of each record remains constant as you're writing it. Therefore, when you're reading it, you're just reading it. You don't need, if I read it twice, I would read two of them. I don't need to look for anything. You follow what I'm saying? Not only that, they are facilities that allow me to go wherever I want in the file, called seek. I can say, hey, file, seek G. Now, what the heck is that G over there? Okay? Because I stream and F stream are both inherited from IO stream. And then they are multiple inherited back to F stream. Now, if F stream wants to seek to certain address, to jump to certain address, it couldn't call the function seek, because seek belongs in both. Then they had to actually write file, scope resolution, IF stream, scope resolution, seek. Long thing. They said, and C programmers hate to write long stuff. So they said, for IF stream jumping to an address, we're going to call it seek G for get. Not forget, I'm not, remember. We're going to call G for, comma, get, okay? And for O stream that I want to write, OF stream, I'm going to put seek P. It means to put something in a file. So G and P stands for that. So now in here, it has to get casted. This is an old one. This doesn't accept it, but it's okay. So that's type safety. Sorry about that. Okay, so see what's happening over here. I'm saying file seek G size of V multiplied by 3. It means from the beginning of the file, go to size of a double multiplied by 3 and go forward. So what happens? It's going to go right before the fourth double. Then I'm going to say now read. So it's going to read. Then I'm going to go seek end 0. What does it mean? This says from where. So seek as an overload. If you just put 1, it means absolute address from the beginning of the file, where to go. If you put this one, you have an offset from where. And there are 3 of them: current, beginning, CUR, BEG, and END. You can say from beginning go to, which is essentially that one, no difference. You can say from current position go backwards. You can say go to the end and stay there. So when I do this, it means go to the end of the file. Now I'm saying, tell me where you are in the file. I'm at the end of the file, right? And from there, come one back, one size of a double back. Now read, which means I'm going to read the last element. Or I could have said over here, seek G end to minus size of V, which means go to the end, come back, and read. So now I can go back and forth in a file. I could not do that with a text file because the records are not damn the same time, same length. One person's name is Lin G. That's what 5 characters? Mine is Fardat Salimamli. It's like 50 characters. So each one is different. You have to have some kind of a delimiter. Look for backslash in to see where is the next record. Look for comma to see where is the next field. Crazy. With this, you create a class with all attributes, dump the whole class in a file, and then read the whole class. Everything goes back to its place. You don't need to have a delimiter. I know we're going to waste lots of space, but we have lots of space now. When you are dealing with files, with text files, you adjust the records to what it is. But with binary files, all the records are the same size. No problem. You save everything and you're done. But be careful, you cannot save classes with resources. Remember that. Classes with resources, if you save it, what's going to happen? It's going to save where the address of the name was at the moment that you were saving it. And then you bring it back, it's not going to work out. I'm going to show you how to do it. That's called indexing. So what you do when you are saving something in a file, you save 2 files. One is data and the other one is the index. And when you are saving for example, employee, and the name is dynamic, you save the employee, and then you actually write where the address of the employees is in another file. And then you do that. You seek PNG. This is what you do easily in databases using indexing. You have an index, you jump to an index, that's what it happens. Hashing, indexing, all those stuff. But again, just an example of what binary files do. You go back and forth to it, and you can read different things, from different parts. And as you see, it just reads. It doesn't care what you're doing, where you're at. So everything works perfectly. So that's that. I just want to, we have like 3 minutes. Okay, I'm not gonna even go to this binary files. Don't study this. Okay, I'm gonna have one lecture right from the binary files. Just understand that from now on, instead of interpreting what's inside a class and write the text version of it in a file, we just do a Xerox copy of the memory of the thing and put it in a file. Later, I'll show you how we can actually have any type of things in a file and have access to our data very quickly. Questions? So don't study this. I'll talk about it later. And sorry if we wasted lots of time at the beginning. If we didn't have that thing, I would actually go through everything properly. But it didn't happen. It happens, you know, Murphy's Law and all the good stuff. Are we okay? All right. I'm happy that you're actually saying you're okay. Anyways. And good stuff are starting now. You'll see, well, like 3 weeks from now, all these things got to be child's play when we get to multi-threading and things like that, okay? All right. Have yourself a beautiful day, everyone.